Hi everyone, it's Mrs. Summer here to talk about 308, the Unit 3 review. So the first question says, Joanne was at home bored on the weekend. She decided to do an experiment. She had seen someone put Mentos in Diet Coke and wanted to try it herself. When she was doing this, she wondered if it was in a chemical reaction. What would you tell her? What evidence of a chemical change would you use to support your claim? So if you think about it as with Mentos and Diet Coke, it is a chemical reaction, and what you see is gas produced. So you see gas produced from there. So I would say yes, there is an evidence of a chemical reaction because a gas is being produced when she puts the Mentos into the Diet Coke. And then the second one, Jeffrey was cooking eggs for breakfast and wondered if it was a chemical change. What would you tell him? What evidence of a chemical change would you use to support your claim? And I would say, yes, it is a chemical reaction. It's a chemical reaction due to color change. Question 3 says, label all of the parts of this chemical equation. Use vocabulary terms to make sure you label everything. So these two things are the reactants. The small letter is our subscript. This arrow is yield. The two things after the yield are our products. And that number that comes in front is the coefficient. The sentence describing the above reaction is methane. The sentence is methane and oxygen react to form carbon dioxide and water. So the reactants in this chemical reaction is CH4 and O2. The products in this reaction are CO2 and H2O. Question 7 says, describe the difference between what coefficients and subscripts mean in a chemical equation. The coefficients are the number of each molecule. The subscripts are the number of each atom. In questions 8 through 14, it's asking us to count the number of each atom for the following compounds. So in question 8, there are 2 hydrogens, there's 1 sulfur, and there are 4 oxygen. Question 9, there are 3 lithium, there are 6 hydrogens, there are 3 phosphorus, and there are 12 oxygens. In number 10, there is 1 chromium, there is 4 manganese, and there are 12 oxygens. In number 11, there are 12 hydrogens, there are 2 sulfurs, and there are 8 oxygens. In question 12, there are 4 leads, there are 8 nitrogens, there are 2 times 3 is 6 times 4 is 24 oxygens. And in question 13, there are 2 calciums, there are 2 times 2 is 4 times another 2 is 8 carbons. Hydrogens, there's 3 times 2 is 6 times another 2 is 12 hydrogens. And oxygens, there are 2 times 2 is 4 times another 2 is 8 oxygens. In number 14, we have carbons, there are 14 of them, and sulfurs, there are 14 of them. So the process you use to find the numbers of each atom is I multiply the subscript by the coefficient. In questions 15 through 18, it says, label the following reactions as one of the 5 types, and then explain how you know it's each reaction. Well, I have Al, I am adding 2 things to get 1 thing, so this is a synthesis, because I'm adding to get 1. This CH4 plus O2 yields CO2 and H2O. This is combustion. I know this because I am reacting a hydrocarbon with oxygen to get carbon dioxide and water as my product. My number 17, AgNO3 plus Cu yields CuNO3 plus Ag. This is a single replacement. I know that because here and here, they kind of swap places. And we're left with our metals. So the silver and copper switch places. In number 18, it's Ki plus lead nitrate yields lead iodide and potassium nitrate. And this is a double replacement. And I know that because the 2 metals swap places. And then the last one is 2Ni3 yields N2 plus I2. And this is a decomposition and I know that because 1 thing becomes 2. In the remaining questions, it says balance the following equations. So I'm going to make my table, and I'm going to write my reactants and my products, and I have Mg and N, and so on my reactant side, there's 1 magnesium, and on my reactant side, there are 2 nitrogens. And then on my product side, I have 3 magnesiums and 2 nitrogens. So my nitrogens seem to be balanced, but my magnesiums are not. So I am going to put a 3 here, and now my magnesiums are balanced. This next question was, I'm going to write again my chart, and I have B, Cl, H, and O, B, Cl, H, and O, so my reactants, my products. So I have 1 boron. Chlorine, there are 3 on the reactants, hydrogens 2, oxygens 1. On the product side, there is 1 boron. Chlorines, there's 1. Hydrogens, there's 4, because remember 1 and then 3 is 4. And then oxygens, I have 3. So remember to save your oxygens and hydrogens till last. So how I'm doing this is I'm going to balance my chlorines first. So I am going to put a 3 there to try and balance my chlorines. And when I do that, I change that to 3. Now I have 3 hydrogens here plus 3 hydrogens there. And so I have 6 total hydrogens. Now over here, my borons are balanced, my chlorines are balanced, my hydrogens are not, and my oxygens are not. So what I have to do is I'm going to put a 3 on my reactant side in front of my H2O. So then I get 6 total hydrogens and then 3 total oxygens. And then if I look straight across, the elements are the same on both sides. The atoms are the same number, and so therefore it is balanced. So here's a chart, and I've already listed the starting number of atoms on both sides. And so if you look, my calcium seem to be balanced, my silicones seem to be balanced, oxygen's not, hydrogen's not, and fluorine's not. So we're going to save oxygen and hydrogen until the end. Fluorines, I have 6 total on the products, but only 1 total on the reactants, which means I'm going to put a 6 here. And by doing that, I now have 6 hydrogens on my reactant side, but only 2 on my product. Now, everything else seems to be balanced except for those hydrogens and oxygens. Well, hydrogen only exists over in this water on the product. So to make that hydrogen 6, I need to put a 3 there. When I do that, I get 6 and I get 3, and look, my oxygens end up balanced. In this example, I have 2 aluminums on my reactants, and I have 1 aluminum on the product. I have 3 oxygens on the reactant, and I have 2 oxygens on the product. So I'm going to start by putting a 2 here. Let me change that color. But by putting that 2 there, I still don't balance my oxygens. So by doing that, now I need to go back and balance my oxygens. Well, I have 3 on the reactant and 2 on my product, which means I have to make it into a least common multiple because 3 and 2 are not factors of one another. So what is the lowest number that 3 and 2 are factors of? And it's 6. So I am going to put a 3 here to make it 6 oxygens on that side. And I need to put a 2 here because 2 times 3 is 6. But then my aluminums get unbalanced. But that's easily fixed by putting a 4 here. So sometimes it goes back and forth and you have to just do trial and error. So here's the chart set up for this next reaction. And you can see that nothing is balanced on either side. So remember, we leave our oxygens and hydrogens until the end. So then we can either pick our aluminums or our sulfurs to balance first. I'm going to pick aluminum and I'm going to put a 2 there. By doing that, my numbers change and I'm left with 2 aluminums, 10 oxygens, and sorry, that 8 looks really bad, so I'm going to rewrite that. 8 hydrogens. And now my sulfurs are still not balanced. I'm going to balance them by putting a 3 in front of my H2SO4. And when I do that, I end up with 18 oxygens on the reactants, 12 hydrogens on the reactants, and 3 sulfurs on the reactants. Now, if I look over on my product side, well, I have 12 hydrogens on the reactants, but I only have 2 hydrogens on the products, which means I need to put, I'm sorry, that is not the number I need to put. I need to put a 6 in front of that hydrogen or the H2O to balance it. And I end up with 18, I end up with 12 hydrogen on my product side. I also end up with 18 oxygens. And if you look straight across, you know that you have the same number of atoms on both sides of the equation. For this next reaction, and I'm hoping it doesn't get cut off in this recording, I'm really hoping it doesn't, but it might. So we have Na. So we have 1 sodium on the reactants and products. We have 2 hydrogens on the reactants and 3 hydrogens on the product. And on the oxygens, we have 1 and 1. So it's the only thing that's not balanced is our hydrogens. So I'm going to start by putting a 2 in front of that H2O. And when I do that, I end up with 2 oxygen and 4 hydrogen. Well, then I need to, my hydrogens are still not balanced and my oxygens are not balanced anymore. Well, I'm going to put a 2 in front of that NaOH on the product side. So now I have 2 and then 2 oxygens, and I have 4 hydrogens. And what I'm left with is my sodiums are now unbalanced, and I need to put a 2 in front of my sodium. And now I'm balanced. So the coefficients are 2, 2, 2, and 1 for this reaction. And your answers will vary on this last question where it says choose one of the above balancing problems to explain how you balanced it. Make sure you use coefficients, subscripts, reactants, products, and number of atoms. So your answers will vary on that question. But I walked you through how I solved all of my balancing questions, so you should be able to reason your way through those questions, through this last question.